I'm going to briefly demonstrate how to use an interactive simulation that models enzyme kinetics and enzyme kinetics with inhibition. The simulation is located on the LearnChemE site, and it's modeling the Michaelis-Menten enzyme kinetics for 4 types of inhibition. So the simulation is represented here, a plot of 1 over the rate with a minus sign because we're using up the substrate, 1 over the rate of the substrate reacting versus 1 over the concentration. Now this particular plot, known as a Lineweaver-Burke plot, yields a straight line for some types of inhibition and for no inhibition. And so what we're going to do is look at the simulation now and see how the behavior changes. The black dashed line corresponds to enzyme kinetics with no inhibition, and the blue line corresponds to inhibition for the concentration that can be changed with the slider. So here's the simulation. You can see as I increase the inhibitor concentration, the blue line slope gets steeper. Remember, this is minus 1 over the rate, so that means the rate's getting lower. And for different types of inhibition, in this case, as I change the concentration, the slope doesn't change, but the intercept does. And for non-competitive, the slope and the intercept changes. The intercept changes on the y-axis here. So the simulation also allows you to look at what Michaelis-Menten enzyme kinetics, where now we're looking at minus the rate of the substrate versus substrate concentration as the inhibition is decreased. Here are the equations and the symbols used to develop this simulation. And the idea is hopefully by looking at how different types of inhibition changes the rate of reaction, we get a better understanding of these kinetics. The last one to look at, self-inhibition. Now we're plotting minus 1 over the rate versus 1 over the substrate concentration. We no longer get a straight line because the enzyme concentration, as it increases, moving to the left, it inhibits the reaction, and therefore 1 over the rate gets larger.